Welcome to the MathLab channel. Today I will be discussing the sketching of quadratic graphs for Sec3 and Sec4 EMATs. The sketching of quadratic graphs is a question that comes out in almost every examination paper. We have to know how to sketch quadratic graphs when the expression can be factorized, and we also have to know how to sketch the graph if you have to first complete the square and then identify the key features of the graph, such as the turning point or the y-intercept. I'll be covering both these cases today, and I'll also be going through two worked examples with you. In the first variation, the function can be factorized, or it has been already factorized for you. For instance, you might be given the expression y equals to k times x minus a times x minus b. This is a quadratic function that has been factorized. If you are given the function in factorized form, we can immediately deduce that the graph intersects the x-axis or the horizontal axis at the points A and B. When the graph is sketched, the graph would pass through the points A, 0 and B, 0 on the x-axis. So why does the graph pass through these 2 points? It is because on the x-axis, the y coordinate is 0. The y value is 0. So when you solve the equation y equals to 0, in other words, when we solve the equation k times x minus a times x minus b equals to 0, you get the solutions x equals to a and x equals to b. So that explains why the graph intersects, or the graph cuts the x-axis at the points A and B, namely the points A, 0 and B, 0. When the coefficient of x squared is positive, we know that we get a smiley face, right? And when the coefficient of x squared is negative, we get the sad face. All right. So when k is positive, when k is bigger than 0, the graph would be the smiley face shape. It would be something like this. Okay? It passes through the x-axis at A and B. Okay? So mark out the points A and B. Okay? And often you would be asked to determine the line of symmetry or the coordinates of the turning point. In this case, when k is positive, we have something known as a minimum graph. In other words, a graph that has a minimum point. Right? So how to determine the turning point, or in this case, the minimum point? We take the average of A and B. We take A plus B divided by 2. This gives us the x value. Okay? This gives us the x coordinate of the turning point. Okay? The same concept applies when k is less than 0. Only the shape changes. You get a sad face shape. Because when k is less than 0, the coefficient of x squared is negative. The graph still passes through A and B on the x-axis. In this example, we get a maximum graph. In other words, a graph that has a maximum point. Okay? So similar to the case when k is positive, the x coordinate of the turning point is given by the average of A and B. In other words, A plus B divided by 2. So this also gives us the vertical line of symmetry. Every quadratic graph has a vertical line of symmetry passing through the turning point. So if you're asked for the line of symmetry, give the line of symmetry as x equals A plus B divided by 2. So this is how we sketch the graph when the function is factorizable or the function has been factorized for you. There is a second scenario when you have to complete the square. Let me go through this scenario now. When the graph is given in this form, y equals k times x minus a bracket square plus c. This is the form that would be obtained if you complete the square for the quadratic expression. So this is the second scenario. When you are given the graph in this form, we can use this form to deduce the turning point of the graph. In this case, the turning point is the point A, comma C. Okay? The point A, comma C. Okay? A, comma C, that will be the turning point. All right? Okay. Again, similar to the first scenario when the expression was factorized, k bigger than 0 is the case when the coefficient of x squared is positive. So that's when you get the smiley face shape. So when k is bigger than 0, the graph would be something like this. Smiley face shape. The graph would be a minimum graph. That means a graph having a minimum point. And the minimum point would be the point A, comma C. When k is less than 0, we get the other shape because the coefficient of x squared is negative. So we get a graph resembling this. The maximum point in this case is still given by A, comma C. So that's the maximum point. And in both cases, the line of symmetry, okay, the line of symmetry is given by x equals to A. X equals to A is the vertical line of symmetry. Okay? So just remember, for all quadratic graphs, whether it's something that can be factorized or whether it's something for which you have completed the square, the vertical line of symmetry is the line passing through the turning point, passing through the minimum point or the maximum point. Let me discuss two concrete examples with you. Example 1, y equals to 2x squared plus 5x minus 3. Okay, this is a function that can be factorized. So let's factorize the expression. The expression is equals to 2x minus 1 times x plus 3. Okay. So this belongs to the first category I discussed just now. The x-intercepts, or the points where the graph intersects the x-axis, is given by negative 3 and positive half. Let me note that down. X-intercepts are positive half, negative 3. And furthermore, the graph is this shape, okay? The smiley face shape, because the coefficient of x squared is equals to 2, and that's a positive coefficient. So when you sketch the graph as a smiley face, okay, passing through negative 3 and positive half on the x-axis. Okay, negative 3, positive half on the horizontal axis. Now be sure to sketch it so that the graph is proportional, passing through minus 3 and half. If the question asks you for the coordinates of the turning point or the line of symmetry, you have to take the average of the x-intercepts. So take the average of negative 3 and half by adding the two numbers n and dividing by 2. That gives us negative 1.25. You can also write it in as an improper fraction, negative 5 over 4. Okay. So the line of symmetry, I'll just use a short form. The line of symmetry of the graph is x equals to negative 5 over 4. You can indicate the line of symmetry using a vertical dashed line passing through the turning point. If you are asked for the coordinates of the turning point, we also have to find the y value. The y value can be found by substituting negative 1.25 into the given expression, okay? Into the quadratic expression that you are given. So substituting x equals to minus 1.25 into the given quadratic expression, you will get y equals to negative 6.125. You can check this using your calculator. So the coordinates of the minimum point is equals to negative 1.25, comma, negative 6.125. Sometimes you might be asked for the y-intercept. The y-intercept is the point where the graph intersects the y-axis. So that is the point where the x value is 0. In this example, the y-intercept is the point 0 minus 3. Okay? It is because if I substitute x equals 0 into the expression, you will get negative 3. So 0 minus 3 is therefore the y-intercept. Example number 2, I want to go through the case where you are asked to complete the square for a given expression. Okay, the example is y equals to negative 2x squared plus 4x plus 5. Okay. Suppose the question asks you to complete the square and sketch the graph indicating the important features of the graph, such as the turning point and the y-intercept. In order to complete the square, we first factorize out negative 2 from the first two terms. This is done because in order to complete the square, you have to make the coefficient of x squared positive 1. Okay? So you factorize out negative 2 from the first two terms and complete the square for the expression within the bracket. Okay? So we focus now on the expression that's within the square brackets. We complete the square for the expression x squared minus 2x. So we add two over 2 square and subtract the same term. Okay. The first three terms is of the form x squared minus 2x plus 2 over 2 square. So that is an expression of the form a squared minus 2ab plus b squared, which can be factorized. This expression can be factorized into x minus 1 bracket square. 2 over 2 square is thus 1. Okay. So within the square brackets, you get x minus 1 bracket square minus 1. Okay. Now we multiply in the negative 2 and simplify. Okay. Negative 2 times x minus 1 square plus 2 plus 5. So that gives us negative 2 x minus 1 bracket square plus 7. Okay. So that is the process of completing the square for this example. Okay. From the completed form, we can deduce that the turning point is 1, 7. Okay. 1, 7 is the turning point. In this case, it is a maximum graph because the coefficient of x squared is negative 2, and that's a negative coefficient. So you should be getting a maximum graph, which is the set phase graph, okay? A graph of this shape. So we sketch the graph in this way. The graph passes through the turning point 1, 7. So this would be a sketch of the graph. Okay, indicate the turning point. Okay. If they want you to state the line of symmetry, then state the line of symmetry as x equals to 1. Okay. The vertical line passing through the turning point. If you're asked for the y-intercept is simply 0, 5. That's because when x is 0, y is equals to positive 5. Okay. So that's how you sketch this graph after you have completed the square for the expression. Okay. So in most exam questions on quadratic graph sketching, you would be given either the first example or the second example. So be sure to know how to handle both cases. I hope you have enjoyed this video and come back for more videos.